at section 10.1 of Math 8, where we're going to learn how to model and solve what they call one-step equations. Now remember, for modeling, we like to use these algebra tiles, and we've used them in class a bit, I hope you've seen. I'm going to be using them here. We're going to be drawing pictures instead, but imagine having them in front of you. Recall that a positive variable is a solid rod, and the numbers that are positive are these small little squares. A negative variable, you guessed it, the rod that is unshaded or empty. Similarly, the -1 represents a little tiny square or box that is unshaded. So the questions we're going to do today are what we call one step. So in one step, you should be able to solve them. And here's our first example. It says solve 4x equals to -12. So 4x means 4 times a particular number that we don't know, equals to -12. So I'm going to show you 3 methods, okay? First one is called by inspection. That just means you can solve it by looking at the question. So you're asking yourself, what number multiplied by 4 equals -12? And if you answered -3, you are definitely correct. So that's it. By inspection, I just know it's there. I'm going to now show you another method by modeling with algebra tiles. So I've already drawn your picture. 4x is your 4 rods, and -12 are your -12 or 12 unshaded squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. The key here is to try to group them. Okay, so what I'm going to do underneath is redraw the same 4 rods, and please, you do it in your notes as well. So 1, 2, 3, and 4. And your goal is to try to regroup all those small -1s. Now, grouping like this. I start with the first rod. There's 1, 2, 3, 4. And once I'm done there, I'll go back to the top. 5, 6, 7, 8, 9, 10, 11, 12. And now, once you've drawn it like this, my question is, can you actually group these? So I believe there's a group here, another group here, a third one here, and a fourth one here. Now remember, the goal of algebra here says, what value must one positive variable tile have? So what you want to do now is just focus on one of the groups, and I'll focus on the last one here. And notice in this group there is one positive variable tile, which represents my x. And over here I've got 3, and that represents 3 negatives. So there you have it. X equals to -3. Okay, that's how you model, by drawing pictures. Now, the third method is called opposite operation. And so this is where you're given the question again, and let me write it out. 4 times x equals to -12. And you have to ask yourself, this is 4 times x, so what is the opposite of multiplying by 4? And if the answer is dividing by 4, you are definitely correct. And so the key here now is to divide both sides by 4. So I'm going to put a divide by 4 here on the left and a divide by 4 on the right. Well, 4x's divided by 4 just gives you 1x. So 4 divided by 4 is 1, so that's why it's 1x, or just x. And then -12 divided by 4 is just -3. So that's why we call these one-step equations, because there's your one step, and then you're done. Okay? So I'd like you to try the next one on your own as an exercise. I'd like you to pause the video and do it whichever way you wish. My suggestion would be just solve it. And I do want you to know how to draw them, but I also want you to know opposite operation for sure. Okay, so go ahead. shows negative x equals to negative 7. You're solving for a positive tile though, careful, so I have to get rid of this negative somehow, which I will just, I guess, divide or multiply by negative 1, because then I get a positive, and you get positive 7. Okay? If you did the opposite operation method, negative 3x equals to negative 21, what's the opposite of multiplying by negative 3? It's dividing by negative 3. And when you do that, you just get x on the left and positive 7 on the right. Cool, cool? All right. Next. So here's another example now. And this time we're asking you to solve a division question. So some number n divided by 5 equals to 3. By inspection, that just means you should just know it. Well, what number is that? Something divided by 5 equals to 3. If you said 15, ta-da, you are right. Okay. If you can't figure that out right away, well, let me show you how to do them by algebra tiles. The goal here is to ask yourself, how do we show n divided by 5? Well, n is a solid rod, so let me draw my solid rod here. Okay, shade it in. But this is divided by 5, so I'm going to divide this into 5 pieces now. 1, 2, 3, 4, 5. And what I'm saying is now, let's focus on that last piece, so this fifth. N divided by 5 means 1/5 of n. And that last piece is equivalent to 3, which means it's 3 solid small squares. Okay? Now, if this equals to 3, our goal is to say what value must one whole positive variable represent? Meaning, I want the whole thing shaded in. So I guess that means each of these pieces is equal to 3. So my question is, what would one full piece here be equal to? Well, notice what I just said was each of these pieces equals to 3. So I guess that means I would have to make 5 copies of 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And therefore, in this case, n equals to, that's right, 15. Okay. All right, well, opposite operation is the third method. So what is the opposite of dividing by 5? So let me just quickly write this down again. We have n divided by 5 equals to 3. The opposite of dividing by 5, can someone tell me? Somebody out there, tell me. Multiply by 5. So I'm going to ask you to just multiply by 5 on both sides. Now, when you multiply by 5 like this, you get 5 times n divided by 5. So the 5's just disappear and become the number 1. So we have now n equals to 3 times 5 is 15. Done. All right. One last example, and then you should be set to work on some questions. So here's example 3. Solve negative t over 2 equals to negative 4. Once again, I'm going to ask you to do it not just one way, but in this case 2. We'll model with algebra tiles, and then we'll do opposite operation. Okay? A negative t, so that's a tile that is unshaded. I'm going to divide this by 2, so I'm going to cut this in half. And this is equivalent to negative 4, so 1, 2, 3, 4. So what I'm saying here is just this one part here, okay? 1/2 of the whole rod of t, or negative t, sorry, equals to negative 4. So the goal here, once again, is to find one entire rod. And if each of these parts here is negative 4, that means this one here is also negative 4, which means I need to do what on the right-hand side? I need to double it, right? 2 pieces there. And so what this tells me here is I've got negative t equals to negative 8, which is fine, but we're not done yet, because in modeling, we're trying to solve for not a negative variable, but a positive variable. And so now how do I change a negative into a positive? Well, we can either divide or multiply by negative 1. And when we do that, okay, this just flips into a positive 1. So the unshaded becomes shaded, and similar with the other side, all of the unshaded now become shaded. So once again, what's happening here? We get t now equals to positive 8. And that's our solution for this question. Okay. We'll do opposite operation. And by the way, I do want you to get used to the opposite operation method. Although I am teaching you both the picture drawing with modeling with algebra tiles and the opposite operation, when you move on to higher grades in math, I hope that you're not going to be continuing to draw pictures because it takes too long. So please get used to the opposite operation method, but right now, if the pictures help you, use that to help you learn. So ask yourself, what's the opposite of dividing by 2? Well, I think it should be multiplying by 2. So once again, negative t over 2 equals to negative 4. And the goal here is to now times both sides by 2. So 2 times negative t over 2 just becomes negative t. And then negative 4 times 2 is negative 8. Once again, we have that dilemma of we want to find positive t, not negative t. So I guess there's one extra step here for this one. I'll divide by negative 1. And by the way, you can multiply by negative 1. It doesn't matter. But multiplying and dividing by negative 1 is where you can change the signs or flip them. And so we now have positive t instead of negative t. And instead of negative 8, we have positive 8. And once again, the same answer as the one we got when we modeled with algebra tiles. All right, I hope you've got this done and have understood this. Now it's time to try some questions.